Alright, welcome back everybody. In this video we're going to look at the first couple of examples from the Substitution Part 3 lesson. These are more difficult or sometimes tricky substitutions, or multiple substitutions, or things where we need to split the integral into multiple parts in order to best integrate them. Alright, so let's look at example 1. We're going to integrate x times the quantity x minus 2 to the 7th dx. Now I could, if I really wanted to, expand the quantity x minus 2 to the 7th power and then just integrate like that. I don't know about you, but I have very little desire to expand the quantity x minus 2 to the 7th power. And because of the way this integral is laid out, I can make it a whole lot easier by using substitution. The substitution I'm going to choose is this quantity that's being raised to the 7th power. So I've got u equals x minus 2, and then du equals dx. And if I tried to do this substitution this way, I would replace the x minus 2 to the 7th with a u, and I would replace the dx with a du, but I still have this pesky leftover x out in front here to deal with. And that's what makes this a little trickier of a substitution. I need to replace that x with what it's equal to in terms of u, and that's not terribly difficult in this particular problem. Since we know that u is equal to x minus 2, if we take this expression and just add 2 to both sides, we get the relationship that x is equal to u plus 2. And so I can replace this x with the quantity u plus 2. Now, how has this helped us out? Because I still have an expression that looks a little bit like the original, which we said we didn't want to expand the quantity x minus 2 to the 7th power. And we don't have a rule for taking the integral of products. So how did this help us out? Well, I can distribute the u to the 7th through the parentheses, and this turns into the quantity u to the 8th plus 2u to the 7th du, which is now something that I can just integrate term by term. We get u to the 9th over 9 plus 2 times u to the 8th over 8 plus c. Or, bringing u back, we've got the quantity x minus 2 to the 9th over 9 plus the quantity x minus 2 to the 8th over 4 plus c. And there's our integral of the original, without us having to expand that binomial to a very large power. We've arrived at an effective integral for this particular problem. Alright, let's take a look at example 2, and that just looks ugly. We're going to integrate the quantity negative quantity 32x minus 20 times the quantity 4x squared minus 5x times the cosine squared of the quantity 4x squared minus 5x quantity squared times the sine of 4x squared, and I'm missing a dx out on the end here. 4x squared minus 5x the quantity squared. So, golly, I'd like to make a substitution here. The most complicated function that I have here is this cosine squared of 4x squared minus 5x to the 2nd. And I have, that's really the cosine. The way we want to think about this is that it's the cosine of the quantity 4x squared minus 5x, quantity squared, that whole quantity squared. So I think I'm going to try as my substitution u equals the quantity 4x squared minus 5x, the quantity squared. And we'll see what happens when we do that. So the derivative of that is du equals 2 times the quantity 4x squared minus 5x times the derivative of the inside, which is 8x minus 5, dx. Alright, so we're going to replace this 4x squared minus 5 with a u, and this 4x minus 5 squared with a u, and this 4x squared minus 5x with a u. And then let's see what all we have left over. So we're taking care of the cosine squared and the sine. We've got cosine squared of u, sine of u. And then let's see, what else do I have here? I've got a 4x squared minus 5 in there. That's right there. And this is a 16x minus 10 if I multiply the 2 and the 8x minus 5 together. So if I multiply this whole thing by negative 2, I end up with the opposite of 32x minus 20 times 4x squared minus 5x times dx. And so I'm going to replace all of that with a negative 2 du. Alright, now, it's still not something that I can readily take the integral of. So I'm going to have to make another substitution. And the substitution that I'm going to make is I'm going to replace the cosine of u. And so I'll use another variable. I'll just go ahead and use t, since that's a variable we haven't used yet. If t is the cosine of u, then dt is negative sine of u du. And so negative dt is equal to this sine of u du. So I can bring the negative sign out in front. And this just turns into the integral of t squared dt. And now I can go ahead and integrate. The integral of that is going to be t to the third over 3 plus a constant. And then I want to bring t back. So I've got 2/3 times cosine of u to the third. And then I want to bring u back. 2/3 cosine of the quantity 4x squared minus 5x, all of that to the third, plus c, or 2/3 cosine cubed of the quantity, oops, when I brought my u back, I forgot my second power. And there's my integral for that very complicated looking function. So sometimes it's necessary for us to make multiple substitutions in order to find the integral. Alright, let's continue on. Let's go ahead and do example 3. No, you know what? I changed my mind. We're going to stop there, and we'll come back for example 3 in the next video. See you guys then. Have a great rest of your day.